Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 8, Similarity. We're still doing similarity. All right, so I've got my ruler out already. I'm ready to go. First example, it says in the picture below, we have a triangle ABC. It's this triangle here that has been dilated from the center origin O by a scale factor of r equals a half, and it is noted by triangle A prime, B prime, C prime. So it is right here. So it's closer to the origin because the scale factor is less than 1. It was shrunk down and it's half the size of the original. We also have a triangle A double prime, B double prime, C double prime, which is congruent to triangle A prime, B prime, C prime. So this triangle here and this triangle here are congruent. They are the same shape. They are the same size, same angle measures, same segment lengths. Okay, so now it says describe the sequence that would map triangle A double prime, B double prime, C double prime onto triangle ABC. A sequence. Okay, sequence is more than one transformation. So since this has been scaled down a half, in order to get it back to the original size, I need to double it. So we are going to scale it up by the reciprocal of a half, which is 2. So if I draw a line through A and continue out this way, there's my line through A. Then I'm going to rotate this and translate out, or draw a line segment out from O through C prime and continue out this way. And then finally my B is right here. So those are the 3 segments that we're going to use to dilate this. And remember from our last lesson, we don't have to measure anymore. We can use the coordinates. So if A double prime is at the coordinate 11, 4, I'm going to use that. If I double it, it's going to end up at 22, 8. Okay, and that is right here. And I'm on the same line, or ray, I should say. These are rays. I'm on the same ray as OA prime, A double prime. So now I have a point out here, and that's going to be A triple prime. And that is the point 22, 8. Okay, so let me change colors for my other points. So B double prime is 13 and 5. So B double prime is 13 comma 5. If I double that, 26, 10, here's 26, go up to 10, I am right on that line right there, and there is B triple prime at 26, 10. And then finally, C double prime is at 15, 3. If I double 15, I'm out to 30, and if I double 3, I'm up to 6. And that is right here on this ray. So there is C triple prime. Now I'm going to draw that triangle. So let me put my ruler as accurately as possible on that A triple prime and draw a segment from A triple prime to B triple prime, and do the same down here to C triple prime. So there's 2 sides of my triangle, and then I'm going to slide this over and rotate down like so. So there is my triangle A triple prime, B triple prime, C triple prime, and since I scaled it up 2, it is now congruent to the original pre-image of triangle ABC. Okay, so now that I have this triangle here, how do I get it over here? Well, I don't need to rotate it because it is just a translation. I don't need to reflect it. It's not flipped over. So I just have to determine how many spaces I need to count over and down to get to where I need to end up. So if I start at B triple prime, I have to go left 1, 2. Actually, that's all I have to do is look at my X value. I'm going from 26 down to 6. So that is a decrease of 20 on the x-axis. So if I describe my sequence, then I would say triangle A triple prime, B triple prime, C triple prime has to be translated. And so I'm going to just say that x comma y, my points, are going to end up going to x minus, and I'm going from 26 to 6, so that's a decrease or movement to the left of 20, comma, y, and we're moving down from 10 to 8, that's a decrease of 2. So I'm moving my x left 20 and my y down 2. So if I do that translation, if I grab this here and I move and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and down 1, 2, I am right on top of my pre-image, and it is congruent. Okay, so my sequence was, actually I've only mentioned the first of the two. Let me move these down a little bit. Because this is only the first of my sequence. So triangle A triple prime, B triple prime, C triple prime gets moved from xy to x minus 20, y minus 20. But before that, what did we do? Well, we scaled it, centered around 0. So I would say a dilation, from center 0, which is the origin, with a scale factor of r equals 2. Okay, followed by a translation. So I wouldn't have that triangle A triple prime, B triple prime, C triple prime, okay? And then followed by a translation. So we're going to translate left 20 down 2. There is our sequence that would map our triangle here to here. Okay, so now we're going to look at exercise 2 or 1. Hopefully you can try this on your own. Pause the video, come back, see how you did. Okay, here we go. Triangle ABC was dilated. This is the original pre-image. From the center of the origin down to A prime, B prime, C prime by a scale factor of 1, r equals 1/2. The dilated triangle is noted by triangle prime, A prime, B prime, C prime. Another triangle, double prime, is congruent. These two are congruent. Describe a dilation followed by a basic rigid motion. A dilation followed by a rigid motion that would map triangle A double prime, B double prime, C double prime onto triangle ABC. So I'm not going to bother drawing the rays this time. I'm just going to label my points. And A is at 3, 2. And B, or A double prime. B double prime is at 4, 3. And C double prime is at 5, 1. Okay, if I am going to dilate that up from the origin back to this, I have to do the opposite direction. So this is scaled down by 1/2. The reciprocal of 1/2 is 2. So the first thing I'm going to do is dilate from center 0, from the origin, scale factor of r equals 2. That will get my A double prime from 3, 2 to multiply by 2, 6, 4. So I'm going to go over to 6, up to 4, and here is my A triple prime. And then I'm going to move B prime, double prime from 4, 3 to 8, 6, which is right here. So there's B triple prime. And C double prime is going to move and become, or scale up to 10, 2. And that is going to be right here. And that is going to be C triple prime. I will get my ruler and create this triangle. Okay, so there's my triangle. Okay, so now I need to move that from here to here. And B triple prime is at the point, let's label these. So now we're at 8, comma 6, and this is 10, comma 2, and this is 6, comma 4. Now I'm just going to focus on one of the points. Let's do B. B is at 8, 6, or B triple prime is at 8, 6. The original pre-image B is at the point -4, 10. So in order to get from 8 down to 0, we have to go left 8, and then we have to go left 4 more, so that's a total of 12. So we're going to move the triangle from, so let's just call it a translation. Left 12, and so I went from 8 to -4, it's a distance of 12, and I went from 6 up to 10, and that is up 4. Translation left 12 up 4 would be the same as writing x comma y going to x minus 12 comma y plus 4. So when I do that, then I'm just going to go left 1, 2, let's try that again. And let me close that parentheses here. All right. So let's move this triangle left 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up 1, 2, 3, 4. And we are right there. Okay, so there is a dilation from the center O scale factor of r equals 2, and then a translation left 12 up 4. Okay. Okay, so in this problem here, it's asking us to describe a sequence that would show the triangle ABC similar to triangle A prime, B prime, C prime. So the first thing I would do is I would rotate this so that it is BC is going to be parallel to B prime, C prime. And in order to do that, I would have to rotate this 90 degrees. So if I rotated this 90 degrees like so, that is not where it would end up. If I rotate about the origin 90 degrees, instead of going left 1, up 3, A would end up being left 3, up 1, and my C would end up on my y-axis here. So this would be a 90-degree rotation about the origin right here. So that is my first move. Okay, so the first thing I would say is that rotate triangle ABC 90 degrees about the origin O. So now this is A prime, if you will, because they're calling these primes. So let's not worry about calling it A prime, B prime, C prime. Let's just call it A. Now B would end up here and C would end up here. Okay, so now what points are those? Well, I'm at -3, -1, -3, comma, -1. C is at negative, C is at 0, comma, negative 3, and B is at negative 3, negative 3. Well, if I want to get from 0, negative 3 to here, now I need to dilate this. So if I measure A to B, that's a length of 2. And if I measure A prime to B prime, that is a length of 1, 2, 3, 4, 5, 6. So now I'd have to dilate triangle ABC by a scale factor of R equals 3. So I want AB, that is 2, to be length 6, so I have to multiply that by 3. BC is length 3, and 3 times 3 is 9, and going from negative 8 to 1 is definitely a distance of 9. So therefore, once I scale that up, or by a factor of R equals 3, then wherever that would end up, I'd have to translate it if necessary. Okay. They don't really give me a whole lot of room to do that, so it would have to be translated. It would not end up right here, because if I draw a straight line through B and B prime and C prime and A prime, they are not straight rays, so there would have to be a translation at the end, followed by a translation of some sort. Okay. Number 3. Are the two triangles shown below similar? If so, describe a sequence that would prove them similar. If not, state how they are not similar. Okay, so the first thing I would look at is B prime C prime is 4 units. So if I put BC over B prime C prime, that's going to give me 6 over 4, which reduces to 3 halves. So that would be a scale factor of 1.5 to get, or actually we're scaling down. So we're going from BC to B prime C prime. So we went from 3 to 2, so that'd be an R equals 2/3 because it's shrinking. It's a dilation down. Okay, so if I do the same with the others, if I now look at AC and I'm going to see where A prime C prime ends up, then AC is 18 units and A prime C prime or B prime is 10. That reduces to 9/5. So that would have an R of 5/9. And then finally, AB is 15 and A prime B prime turned out to be 12. Did I mix these up? I think I did. Okay. So AC 18, AC 12. Let's fix this. This should be a 12. And 6 will go into 18 3 times. 6 will go into 12 2 times. So R does equal 2/3 here. Okay, fix that one. And now 15 AB goes to AB, which is 10. And that also reduces. 5 will go into 15 3 times. 5 will go into 10 2. So this is an R of 2/3 as well. Remember, we're scaling down. It got smaller, so it's got to be less than 1. Okay, so our scale factor is 2/3 on all 3 of the sides. Since it is a dilation, the angle measure should be preserved. Therefore, these triangles are similar. Number 4. Number 4. Are the two triangles shown below similar? If so, describe a sequence that would prove triangle ABC similar to triangle A prime, B prime, C prime. If not, state how you know they are not similar. So the first thing I would do is say AB is to A prime, B prime equals BC is to B prime, C prime, and see what those equal. And AC is to A prime, C prime, and see what those are equal to. So AB is 8. A prime, B prime is over here, and that is 10.67. BC is 6. B prime C prime is 8. AC is 3. And A prime C prime is 4. Okay, well 6/8 reduces to 3/4. We are getting larger here, so my R equals 4/3. Over here, R equals 4/3. And if I take 10.67 and divide it by 8, these are not even. I am not going to get 3/4 out of this. So this one is a different length than the others as far as scale goes, because 3/4, 1 1/3 of 8. So if I multiply 8 times 4/3, my scale factor, I should get 12/3, which equals 4. Did I do that correctly? No. Okay, 8 I added. 8 times 4 is 32. And that would be almost, not quite 11. 10 2/3. And this is 10 2/3. So, what do you think? That is correct. Okay, so sometimes decimals are hard to work with, but if you remember the formula, if you take the original times the image or the pre-image times the scale factor, you should get the image. And 10 2/3, 10.67 is rounded. So this is also 3/4. So R equals 4/3. And the angle measure should also be preserved. So therefore, yes, this is these are similar triangles. So what I would do to map let's see, what does it say to do? Describe a sequence that would prove they are similar. Okay, so I could translate from C to C prime. I'm just going to do this quickly like this. I'm not going to get my ruler out. There would be a vector, C to C prime. That would move that there. Then I would rotate until CA was on C prime A prime. And when two lines are on top of each other, they are corresponding. Or not corresponding, they are... Okay, so then they would coincide. AC would coincide with A prime, C prime, and then I would dilate it. So those would be the 3 transformations. Okay, that is the end of lesson 8. Review the lesson summary and go do your problem set.